Good morning, Math 3 students. This is your Week 7 Lesson 2. And today we're taking a look at the Pythagorean Identity. So the Pythagorean Identity is, of course, based on the Pythagorean theorem of a squared plus b squared equals c squared. So as a quick reminder, in the unit circle, the radius is always 1. So if we take a look at any triangle, right triangle, built in this coordinate plane, unit circle, the radius is 1, our horizontal is x, and our vertical is y. So this would be x squared plus y squared equals 1, because 1 squared is 1. So also on the unit circle, the x value is always equal to cosine of theta based on that rotational angle, and y is always sine of theta. So if we substitute cosine in for x and sine in for y, we suddenly have a trig equation. Cosine squared of theta plus sine squared of theta equals 1. That's the Pythagorean identity. So please note that cosine gets squared right here. That is the mathematical way to write it. It's a little less confusing than trying to put like cosine of theta and then the square on it. So just keep in mind the whole cosine ratio is getting squared, but this is how mathematicians write it. You may also see this written as sine squared plus cosine squared, so just the two flipped around. It's the same thing. All right, so how is this going to get used in solving or finding some missing values? Well, here in example 1, it tells us cosine of theta is negative 2/3, and theta is specifically in quadrant 3. So quadrant 3, cosine is negative, while sine will also be negative down here. Tangent's the only positive one. And our job is to find sine of theta using this Pythagorean identity. So cosine squared, let's take the negative 2/3 and square it. And we don't know what sine is. That's what we're trying to find. And it's equal to 1. So let's go ahead and square this fraction, but not with a calculator. When we have a fraction squared, the top gets squared and the bottom gets squared. So a negative is going to square and become a positive. So that's gone. 2 squared is 4. 3 squared is 9. So 4/9 plus sine squared of theta is equal to 1. So if we want to continue working toward finding this sine value, we need to isolate the trig function. So let's subtract 4/9 from both sides. All right, so we're gonna have to use some fractional subtraction or use a calculator here, but 1 whole minus 4/9 is equal to 5/9. So sine squared of theta is equal to 5/9. So just like any equation where your variable is squared, for us to finish solving this, we need to apply a square root to get rid of the square. So sine of theta is equal to the square root of 5 on top and the square root of 9 on bottom. Well, the square root of 9 is 3, so we can simplify that out. And because we are in quadrant 3, we have to make sure we apply a negative because the square root can be positive or negative. Because of the angle where we are, the square root this time is negative. So in Delta Math, we would type in the negative square root of 5 divided by 3. That's the sine value. Let's take a look at another example. Here in example 2, sine of theta is the square root of 3/2, and theta is specifically in quadrant 2. So here in quadrant 2, sine is positive. That's why we see that ratio is positive. But when we come up with the cosine value that they're asking us to find, cosine here is negative. So once again, we'll have to remember to include the negative in our final answer. So just like before, we'll have our cosine squared of theta, that's the one we don't know, plus the square root of 3/2 squared, because we know the sine ratio, and that's equal to 1. So just like before, we'll apply the square to both parts. The square root of 3 squared is 3, and 2 squared is 4. So cosine squared of theta plus 3/4 is equal to 1. So continuing to isolate the trig function, we need to subtract 3/4 from both sides. So 1 whole minus 3/4 is 1/4. So cosine squared of theta is equal to 1/4. And just like before, to finish solving for cosine, we apply a square root to both sides. So cosine of theta is equal to the square root of 1 on top Well, that's 1. And the square root of 4 on bottom, that's 2. So if you can evaluate them or simplify them, you should. And lastly, because we are in quadrant 2, that's a place where cosine is negative. So we have to include the negative. So use this identity, use these examples, head on over to Delta Math, and practice these problems.